All right, these notes are on 6-2, similar figures. Um, right, so what is a similar figure? Is a polygon with the same shape, but different size. Right, typically we'll see different size, but if you see two objects that are exactly the same shape and same size, we would say that those things are also similar. They're just what we call is congruent. Polygons are similar if right, corresponding angles are congruent. So I'm gonna put CONG. Right, so if all the interior angles are exactly the same measure as the other interior angles of another object, right, those are congruent. And then corresponding, so now abbreviate here, corresponding sides are proportional. Okay, so when you think of like similar, I think of like Ant-Man, like how Ant-Man can change different sizes, right? Ant-Man is still the same size, like he's still the same person. It's just a different, same shape but different size. The ratio of corresponding sides is called the scale factor. So think of that as whatever you're multiplying or dividing. And if polygons are similar, then their perimeters are also similar. So the distance around an object. Okay. And we'll look at this object here. So what is the scale factor from the first triangle, triangle ABC, to triangle DEF? So when you're trying to compare triangles here, you want to compare corresponding sides. So I'm going to use right AB. I think that's corresponding to DE. We can see that in the statement as well. AB is the first and the second. DE is the first and the second. So that tells me that, yeah, sure, let's compare those two things. I'm just going to highlight it here so that we know. So in order to find the scale factor, we're going to put this as the first object, that is 8, and the second object, that is 12. So 8 over 12, this would simplify to be 2/3 if you divide both the numerator and denominator by 4. Right, so this is just saying that the first one right here, this is about 2/3 as big as this one. So this one is smaller. Typically, if you see a scale factor that's less than 1, that means it's what we call a reduction. It's smaller. If it's bigger than 1, that's what we call is an enlargement. Okay. So the second one, what is the scale factor now going the other way? So the other way, we're just going to switch this. It's going from 12 to 8. And if you simplify this, right, you would actually get the reciprocal, which is 3/2. So 3/2, if you want to think about this as a decimal, it's 1.5. So you can also say that this triangle is 1.5 times bigger than this one here. Okay. Also, this says the order matters here, right? The order matters from what object you're saying that you're starting with to which one you're saying that you're ending with. And then what is the ratio of the perimeter from this object? So the perimeter, you can add up all of these values here, and then you can add up all these ones here. But if you do add that and then simplify, you're still going to find that it is a 3/2 ratio. So just want you to know that, like, from here to here, right, these are the same, right, exact scale factor. Okay. All right, and let's go to similarity statements. So it's similar to triangle congruent statements. It's just we're not using the symbol for congruence. So we would say that these two triangles are similar. So you would say triangle ABC. The symbol for similar looks like this. It's a little squiggle. It's similar to triangle DEF. Right, we can say that because all the sides are proportional. Or if they had, also we could tell that all the angles are equal. If all the interior angles are equal, so like we could see 1 tick mark, 2 tick marks, 3 tick marks, that tells us that it's also similar. Okay, so that's a for sure way that we can say, because we put it right over here, corresponding angles are congruent and the corresponding sides are proportional, right? They're all going to be 2/3 going from first to second, right? Even if you take 14 divided by 21, you'll get 2/3. 10 divided by 15, you'll also get 2/3. All right, and then we're just going to list out what's proportional or what's congruent here from these two triangles that are similar. So what I would recommend is whenever you're looking at this, sometimes I just write it underneath. So triangle JKL is similar to triangle PMN, so I'm going to put PMN underneath, so I could tell what's lining up with what. So we could say that angle J is congruent to angle P. So it looks like this bigger triangle is kind of tilted on this side. So let's put that here. It is congruent to angle P. Angle K is congruent to angle M. So looking at the second one. And then the third one, put 3 arcs. Right, angle L is congruent to angle N. All right. And then now finally for the sides, so we're going to write this as a ratio. So, or what sides correspond with what? Maybe we can start with this one. I'm going to go from 1 arc to 2 arcs, so that one here. So 1 arc to 2 arcs right here. So this would be JK to PM. And maybe I'll just highlight this the same color. We know that those correspond with each other. Right, next one, we could say from 2 arcs to 3 arcs, from 2 arcs to 3 arcs. Right, this is going to be equal to, right, KL. Right, it's going to be equal to the ratio of KL over MN. And the last one we don't have to highlight, it's just the one that's left over. I'll put that, this is LJ or JL, JL, and 2 PN. Right, as long as we start with that, right? We started with the first arc and then ended with the third arc. Right, first arc, ended with the third arc. Okay, so all of these ratios are going to be exactly the same. All right, let's go to the next part. This here, I'm not going to go into, I'm not really doing this problem, but I just want you to understand, right, we have a big triangle inscribed in a small triangle inscribed in a big triangle. So just be mindful of that when you have various shapes, when you're looking at, right, they have the same shape, but they have a different size. Okay, let's go to the next part here. We'll start with this first one. So number 4, if the figures below are similar with a scale factor of 2 to 3, find the value of x. So we don't know what x is, but we can set up a cross product or a proportional equation. We know that it's going to be 2/3, so I'll write that in fraction form. Looks like a part to whole ratio. And that's going to be equal to, well, if we're saying it's 2 to 3, we're saying it's the first object with the second object. So first object is here, or first side, and then second side. We'll put this as 42 over x. Okay, and this we would cross multiply and divide, right? So cross multiply here and here. I'll put this as 2x equal to, this would be 126. And then if you divide by 2, you would get x is equal to 63. And we would just say that, right, 42 is 2/3 of 63, yeah, because 42 would be smaller than this by that same factor. Okay. Let's go through number 5. I just want to give you one where we're not always going to get whole numbers. In this case, we will get a decimal. This is saying 6 to 5. A 6 to 5 ratio. So I'll put that as 6 over 5 equal to, right? Still going from first object to the second object, so x over 28. So let's cross multiply. We're going to get 5x equal to 6 times 28 is 168. And if you divide both sides by 5, that's not going to go into evenly, but 168 divided by 5. So 168 divided by 5. 33.6. Right. No need to round there because it was a terminating decimal. All right, and we'll keep it like that. So, right, they're not always going to be exactly a whole number, and that's fine. All right, let's go to the last page here, which we have some, I would say, some more kind of complex problems, but I think problems that we need to practice on. Let's start with the first one, then we'll go to some complex ones. All right, but in this case, we're trying to find what is x and what is y. So we're going to set up multiple proportions. All right, so what corresponds with what? If you're not sure, right, that's why we're writing it here. All right, lining it up. If you need to, then right, highlight what's corresponds with what. So like we know that D, we'll say the first two, the DE. So I'll highlight DE. Okay, that corresponds with HJ. Okay. So it looks like those are kind of like the bases here. And we can look at the figure, but I think we can kind of determine right what corresponds with what. Let's go with EF. That corresponds with JG. And I'll highlight the last one that's left over. Okay. So which one do we want to find out first? We always want to use a fraction, fraction or a ratio that has all the numbers. So if you look at purple, we do have a missing value here. Blue, we do have a missing value here. It's the red one that tells us what is the relationship between the two. Right, in that case, it's let's put 9. That's the scale factor there. If we were to simplify it, we could get a more simplified scale factor. But in order to find this, so it's 9 over 15. Let's find blue first. So let's put 14 over y. Okay. All right, so cross multiply and divide. This would be 9y. 14 times 15. Be in the 200s. 210. Okay, and then let's divide that by 9. Divide by 9. All right, 23 point, it's a repeating 3, we'll just round to nearest tens, so 23.3. There we go. All right, this is one of our answers, and we need to figure out what is x, and as you can see there, it's one of the purple ones. I'm gonna keep that same ratio. Let's do, right, 9 over 15 equal to, in order to find y, it's in blue, x, which is in purple, so let's use the purple one, so 12 over x. Okay. So in this case, 9 times x will be 9x, and 15 times 12 will be 180, and 9 can go into evenly 20 times. All right, we found what x is, we found what y is, but let's go through one where we have, looks like we have some binomials here. Let's do number 10. Okay. So in this case, we're just finding what x is, but let's put what is related. We have kxd. Okay. So let's use I'm going to always use the first two, I think, starting out. So ag and kx. So ag, this one. Kx, this one. Okay, so it's saying that those correspond. that if we have the same shape, I don't know why, but to me it kind of doesn't look like that. But let's go to the next one. So let's go with GM, and that corresponds with XD. Okay. And then I think the last one, so AM and KD. AM, KD. And we're probably not going to use the red one because there's no information on either of those. But let's go ahead and write it using the probably purple and blue here. So purple, let's put this as 23 over x plus 3. And then in blue, we'll put 36 over x plus 6. Okay. So with this, we're still going to go through the same process of cross multiplying. But we got to be careful how we multiply because we're multiplying it. It's like using the distributive property. We're multiplying it to two terms. So for the first one, it'll be, you know, I'll write it out. I'll put 36 times x plus 3. And then here I'll put 32 times x plus 6. I'll always put the binomial in parentheses. But if you apply the distributive property, right, this is 36 x plus 108. And this is 32x plus, this would be 192. And then let's subtract. I'm going to subtract this 32 to both sides, and I'm going to subtract this 108 from here. So this would be 4x equal to, that would be 84. And if you divide both sides by 4, you would get x equal to 21. Okay. So, right, the only thing really different there is that we had to, right, apply the distributive property, right, when using the cross multiply and divide method. Okay. All right. You're welcome to do these last two as a you-do, but let me give you your problems. On our assignment, we're only really doing the front side and one problem on the back side. Okay, ignore this, you don't have this paper. All right, so on Unit 6, homework 2, I'm gonna just specifically assign problems here. So we're gonna assign number 1, number 3, and number 4. And then also 7 and 8 on the front side. And the only one I want you to do on the back side is number 9. So don't do anything else there. So how many problems is that? It's 1, 2, 3, 4, 5, 6. Okay, so a total of 6 problems. Okay, all right. Go ahead and begin the assignment, and you can always email me if you have any questions.